Hi there, my name is Dane and I'm currently in the Science Center of Iowa's Innovation Lab. Now in this video we're going to be talking about circuitry and electronics, and we'll be using Tinkercad's new circuitry module to experiment with circuits. All you'll need to do this is a computer with an internet connection and an email address so you can set up your tinkercad.com account. But before we get started, let's talk about what a circuit actually is. A circuit is a closed path through which an electric current can flow. It can be closed or it can be open. Now, when a circuit is closed, all of the components are connected and that allows the electricity to flow through them. But if the circuit is open, then there's a break in that path and the current has nowhere to flow. We can use the flow of that electricity in a circuit to turn things on, like this drill or this flashlight. Now, can you think of anything else that uses an electrical circuit? Some circuits are super simple, like the circuit that powers this light. Now in this circuit, the electricity flows from the battery, through the red wire, through the light bulb, back through the black wire towards the other end of the battery. Now some circuits are very complex and require lots of individual components that interact with other circuits as well, like what we see on this circuit board here. There are lots of small circuits on here, each with their own function. And all of these small shiny lines work like the wires we saw in the last circuit. All these little boxes and cylinders are different electronic components like the light bulb. Usually when I teach about circuitry in real life, I provide a battery and some wires and some electrical components like a light bulb or a motor, what we see here. But like I mentioned earlier, for this video we're going to be using Tinkercad's circuits module. So let's get started with that. Okay, so the first thing we're going to want to do here is go to tinkercad.com, and we are here to tinker. So hit this big blue Start Tinkering button and you'll be directed to this Sign In page. If you don't have an account, go ahead and create a personal account. I already have an account, so I'm going to be hitting this Sign In button. And this is the first thing you'll see. This is your account page, your home page. And right now we're in the 3D design module, but we want to go down to this circuits module. Just select that right below the 3D design module, and this is what you'll see. Hit this big green Create New Circuit button, and it'll take us straight into the Workspace for creating these simulated virtual circuits. Over on the left here is our workspace. This is where we'll add all of our components, our different power sources and wires, and maybe a light bulb or some other stuff that we're going to be experimenting with. And over here on the right is the list of different components. Now there's lots of different types of components. There's some basic components like light bulbs, LEDs, buttons, switches, batteries, but there's also some more advanced ones like breadboards or Arduinos, which are circuit boards that you can program, servos, some motors. That's a little bit more basic, but we also have some transistors, multicolor LEDs. There's lots of different components that you can experiment with. So let's get a circuit going here. We're going to work with some pretty basic stuff, and the first thing we're going to add is a light bulb. At the top of the component list here is a little search tab, and we're going to add a light bulb. Search for a light bulb, and we can see, if we scroll down a little bit, we got a basic incandescent light bulb. You just want to click it one time, and then move your mouse to the workspace, and then voila, click it one more time, and we have added our light bulb to our workspace. Now that it's here, I want to show you, you can sort of navigate around the workspace by clicking and dragging. All right, you can move it around left and right, and if you need to get this light bulb a little bit bigger, just scroll your mouse scroll wheel a little bit closer, or if you're using a laptop and you got a touchpad, just use 2 fingers, slide them towards the laptop or back away from the laptop. That's how you zoom in and out as well. Now that we're zoomed into this light bulb, we can see that there's 2 little nubs at the bottom. These are our terminals, and that's what we're going to be connecting to our power source. Let's go ahead and actually find a power source. We're going to be using a battery. We'll look for that battery the exact same way we looked for the bulb. We'll search for battery, and we're going to be adding a coin battery. Just select that battery there and drag it on in. And oh my goodness, it's getting a little dense on our screen here. We got a lot of stuff on there, so I'm going to zoom out. And the way these are arranged right now, these are the terminals that we want to connect to the light bulb. So actually, I'm going to rotate this battery here. All you got to do that is select it with your mouse and then push the R button. Select it a few times and it has rotated. It's always going to rotate. It's always going to rotate clockwise like that. So let's go ahead and connect these. It's very simple to connect two different electronic components. All you do is select on a terminal there, drag it over. That green line is our wire. So we connected those two terminals, and we can connect these two terminals as well. Now, I don't know how you feel about the way these wires are sort of arranged, but it seems a little awkward, seems a little tight. So what you can do is actually add a bend to that wire. If I double click right in the middle of that wire, that little point shows up. You see that? And I can arrange it so that it's straight up and down like that, and maybe I'll add another one right here. So it's nice and square. I'll do the same thing on the other side as well. Add 2 points, so all those wires are nice and square. Ooh, that looks pretty nice actually. So we have all our wires set up, and you might be thinking, well, why isn't this light bulb turning on? It's because we haven't actually started the simulation yet. If you look in the top right here, we have this nice button that says Start Simulation. If you select that, we'll see that, ooh, our light bulb has turned on. We have created light. You can tell it's on by that nice yellow color that it's emitting, just like a real incandescent light bulb. Now, one thing to keep in mind is that while the simulation is running, we can't move or edit any part of our circuit. So if we want to move the battery around or change something up, we got to stop the simulation, and then we can move stuff around like that. We just created a circuit very similar to the one we saw earlier with our battery and our light bulb, but let's figure out by looking at this circuit here where the electricity is flowing. Like I said, it flows from the positive side, the red side of the battery, all right, through this wire, up through the light bulb, through this little filament here. It heats up, it creates that light, and it comes back all the way around to the negative side of the battery, which is going to be on the opposite side of this coin-style 3-volt battery. So this is an example of a closed circuit, right? All of the components are touching each other. Now, in open circuit, I'm going to copy these here. I'm just selecting both by clicking on one, pressing Shift, and then selecting another one. You can see they're both selected here. If I press Control-C and then Control-V, it makes a copy of those components. The wires did not come with it, but that's fine. What we're going to do is create an open circuit here. All right, so all the components are now not connected. So if I run the simulation, this light bulb turns on. We can see everything's connected, but the components in our open circuit are not connected. So that light bulb will not turn on. Some circuits can turn more than, of course, one electronic component on, right? And one way you can do that is by creating what we call a series circuit. I'm going to show you how to do that. I'm going to, again, copy these components that we're going to be using. All right, but what I want to do is add another light bulb here, because we're going to be turning on both of these light bulbs. Now I'll connect one end of the battery to one terminal on the light bulb, and then connect the other end of the battery to a terminal on the other light bulb, and then I'll create a little path between the two light bulbs using another wire connecting both of their terminals. Let's run the simulation here. We can see both of our light bulbs turn on, and let's follow the electricity, right? It moves from the positive end through this wire, through the light bulb, back out this terminal, back up the other light bulb, and then back through this wire to the negative end of the battery. We have a complete closed circuit, and this is, again, is called a series circuit. All of the components within this circuit share the same wire, and they rely on each other to be working as well. Say, for instance, one of these light bulbs goes out. If this light bulb, if that filament breaks in there, then what you actually do is you open up the circuit. So if this light bulb goes out, then the other light will go as well, because the circuit will have been broken. It'll open up. So if you don't want to worry about that when you're creating a circuit, what you can do is create a different type of circuit called a parallel circuit. Let me show you how to make that. Again, we're going to copy all of our components here. Shift, select, oh, I got to stop the simulation. Shift, select, Control, copy, V. Okay, so we have all the components that we're going to use. What I'm also going to do here is sort of rotate these bulbs a little bit to make it a little bit more comfortable for this circuit. Give it a little bit more space, make it look a little bit more organized. You'll see what I'm talking about in just a second here. In a parallel circuit, each component actually has its own little circuit that it utilizes. Let me show you how to make this. First, let's select the negative end of the battery. we'll drag that to one terminal on one of these light bulbs, and rather than just dragging from terminal 2 to terminal 1 on the next light bulb, from the same terminal, using the same wire, we're going to drag it over here to this terminal, terminal 2, on our other light bulb. So terminal 2 and terminal 1 are connected on these two different light bulbs, and they're both connected to this negative terminal on our battery. Now let's do the positive end. We'll connect this to terminal 1 on this light, and we'll connect terminal 1 to terminal 2. So this might look a little confusing. There's a lot of green happening there. So one thing you can actually do with this is change the color of each of these wires to sort of track the positive and negative ends. If we look real closely at our light bulb, we can see the positive end is red and the negative end is black. That's usually how most electronics work. So let's make those wires match the same colors that we see on the battery, so we can keep track of the negative and positive ends of those wires. Voila. Okay, let's run the simulation and trace the electricity for each of these light bulbs. Let's start with this one over here. The power is moving from the positive end of the battery through this wire. It doesn't have to travel through this light bulb here. It goes straight from this terminal. It passes over this terminal, goes through the light bulb, and then follows this wire back to the battery. That's pretty neat, huh? And we see the same thing in this bulb over here. The power moves from the positive end through this terminal, through the filament, and then follows the negative wire back to the negative terminal on the battery. That's a parallel circuit. This makes it so that if this light bulb goes out, if the filament breaks in there, because this has an independent circuit, the light bulb on the left, it can actually stay on. That's one of the benefits of using a parallel circuit rather than a series circuit that we used before. Now, I'm sure you've used light bulbs before, right? And sometimes you don't want light bulbs to necessarily be on. Sometimes you want to turn them off. So what you got to do when you want to turn the light bulb off is open your wall up, right, and remove the wire from the light bulb. That's how you turn it off, right? Not quite. What you use probably is a switch that's mounted to the wall, okay? We're going to try using a switch in our circuit here. We'll copy all the same components that we were using over here on the right. Let me give them just a little bit more space, and we're going to search for a switch. Now, there are lots of different switches in Tinkercad. We have a standard push button switch, which means when you push the button as you're holding it down, it completes the circuit. And we have a simple slide switch that you might see that's similar to what you see on the wall or on the side of a simple electronic component. And there are, of course, lots of more advanced switches like a keypad, if you want to put in a code or something, and these 6 series SPST switches, which are a little more advanced than what we need to work with right now. But let's grab this slide switch. That's what we're going to be using. Just click it, move it over, and we can see it's a little bit smaller. I'm going to rotate it so it's a little easier to work with, but there we go. We've added our switch. Now let's get close to the switch here. Let's zoom in on it, and let's see what we have here. We have 3 different terminals coming on. We have terminal 2, we got terminal 1, and the common terminal that both of these terminals share. I'm going to show you how to use this switch to turn on both light bulbs, and we're going to just use that series circuit that we started with. So I'll connect the negative end to this light bulb, connect those 2 light bulbs, and then not from terminal 2, we're going to connect the light bulb, this light bulb's terminal 2 to terminal 1 on the switch, and rather than connecting terminal 2 back to the battery, we're going to use the common one. All right, very cool. So we've created our circuit. Let's start our simulation, and right now the light bulbs start on because as the switch is over here, it's closing the circuit, but if I click that switch, you can see we've opened the circuit up. It's slid over here, but what we don't see is that it's actually connecting these 2 terminals to each other. So if we had a whole other set of light bulbs connected to these 2 terminals, then we could turn those on, but we're going to keep it simple for now. Okay, I got a bit of a challenge for you. Using this setup, just 1 switch, 1 light bulb, or 2 light bulbs and a power source, do you think you can create a parallel circuit using this setup with these components? Try it out. Next up, I'm going to show you how you can use this switch to actually turn on 2 different circuits. When it's in this position, it'll turn on this light, and when it's in this position down here, it will turn on the light bulb on the right. Let's try that out. First, what I'll do is copy all of these components, select them all, Control C, Control V, and I'll set them over here. All right, let's create the circuits. First, let's start with the light bulb on the left. When it's in the up position, I want the left bulb to be on. I'll connect the negative terminal to the light bulb, and then this common terminal on the switch is shared by both sides of the switch, okay? So we don't need to do anything other than connect the positive end to the common. Let's connect the negative end of the bulb, or the negative end of the battery to this bulb terminal, and then connect this one to terminal 2. Okay, we will run our simulation. Very good. In the up position, this light bulb is on, and in the down position, this light bulb is on. Let's trace the electricity like we have. The electricity moves through the positive terminal, through the common terminal on the switch, through terminal 2 on the switch, up through the light bulb, and then back down to the negative end of the battery. When it's in this position, the electricity moves through the positive end, through the common terminal, through terminal 1, over to the light bulb, through the filament, and then back to the negative end of the battery. That's pretty handy, right? Maybe you could think of some creative ways you can use a switch to turn on two different things at the same time, other than just light bulbs. Like I said, there's all sorts of different components in here. Now, the type of bulbs we've been using so far are a pretty traditional type of light bulb called an incandescent bulb. The way they work is as the electricity moves through this little filament here, this tiny piece of metal, the electricity heats up that piece of metal and it glows, and that's what creates the light. Another type of light bulb which you may have heard of are LEDs, which we have over here on the right. Now, if we click this button right here, this little view icon, if we select it so it's in this mode, it'll tell us the details about whatever component we're looking at here. So we can see that LED stands for light emitting diode. It's a light emitting diode that lights up when electricity passes through it in the correct direction. That's the kicker. It has to be moving through it in the correct direction. Let's actually talk about what LEDs are, because I have a few. I have an LED here, and all LEDs have these two legs, which are the terminals that you connect to the power source, like the battery. And if you look closely, you'll notice that one of those legs is actually longer. All LEDs are like this, and what that's showing us is which side needs to be connected to the positive side of the battery. That longer leg is what needs to be touching the positive side of the battery. When I slide it over this coin battery, you'll see it turns on. The long leg is touching the positive side. But if I spin it around and have the short leg touch the positive side of the battery, it doesn't turn on. You can see that it's not working, right? Cool. So let's jump back in the Tinkercad and recreate this. So to start a circuit using an LED, we're going to make a little room for it. Select the LED and then bring it on in. We can see it's much smaller than our incandescent bulbs over here. But if we zoom in and look at the terminals on it and hover a little mouse over it, we can see that we have a cathode and an anode. So the anode, see how that leg is a little bent, it's a little bit longer. The anode end of that LED is what we want to connect to the positive end of the battery, and the cathode side is what we want to connect to the negative side. Let's grab another coin battery, and I'm going to rotate it again so it's a little lined up pretty well for us. Let's go ahead and connect all these. We'll connect the positive end, like I said, to the anode, and the negative end to the cathode, and we'll just color the wires so we can keep track of everything. All right, very cool. Let's run the simulation. Voila, we see that it turns on, but if we look closely, we see this little exclamation point. It looks very bright, and this exclamation point is telling us, if we hover our mouse over it, it says current through the LED. The current that's running through the LED is 61.9 milliamps. Amps is how we measure the current, the amount of electricity running through that LED. The recommended maximum for the LED is 20 milliamps. So we have at least three times as many milliamps running through that thing as we should. And because of all that extra electricity running through it, the usable lifetime of the LED might be reduced, which means it's not going to last very long. It's pretty quickly actually going to get burnt out. So in order to get this LED to last a little bit longer, we need to add something called resistance to the circuit. That's what pretty much slows down the amount of electricity moving through the circuit. And we can do this by adding more electronic components. We could add more LEDs, or we could add something called a resistor. Let's find the resistor in our component resistor, and let's see what it says it does. It restricts the flow of electricity in a circuit, reducing the voltage and the current as a result. So it slows down the amount of electricity going through. We'll add it over here, and let's move this end of the wire. Here, we'll just delete this wire, and we'll add the negative end to the resistor here, and then connect this around, and we'll leave those green for now. We'll start the simulation, and let's see if that solved our problem. Voila! It is no longer we don't see that exclamation mark anymore, but it seems super duper dim. I have a feeling we added too much resistance to the circuit. So we can tell how much resistance we added by selecting it. I'm going to end the simulation, click on the resistor, check out the Properties tab for this resistor. We have 1 kilo ohm, which is the same as, okay, we added 1,000 ohms, which is how we measure resistance to this circuit, and that's a little bit more than what we want. There's a really easy way that we can figure out exactly how much resistance we need in a circuit. There's something called an Ohms Law Calculator, which we'll be using. If you just Google Ohms Law Calculator, you can find a calculator right here at rapidtables.com that will allow you to figure out how much resistance you need in a circuit, or how much voltage or current, remember that the amps, you need to get a circuit running well. We can see that it's not a really traditional calculator. We don't have a bunch of numbers that you add up stuff, but all we do with this calculator, if you look at this line here, we just need to enter 2 numbers, all right, 2 of any of these 4 numbers to get the other values. Now we're trying to figure out how much resistance we want to add to the circuit. And we already know the voltage, right? We have a 3-volt battery, so let's go ahead and throw 3 volts in there. And how much current do we need? Let's try it again. I kind of forget how much it said we needed. We'll run it one more time, start the simulation, check it out, and it says we need 20 milliamps. All right? Right now there's 3 times too many milliamps running through there, but we only need 20 milliamps. So let's change this to milliamps, and then write 20. Select this calculate button, and we can see we need 150 ohm resistor to get that circuit to work the way we want it to. So we'll stop our simulation. Let's select our resistor. We'll add it to our circuit right here. All right, when we select the circuit, we just need to add 150 ohms. And when we run it, it's nice and bright, and it's not overloading that light bulb. It should last a pretty long time. Now, we've talked about a lot of different things today, right? We talked about what circuits are, and we've talked about parallel and series circuits, and a little bit about Ohm's Law. If you want to learn more about this, just go back to your Tinkercad homepage. Go over here to this Learn button, and there's some lessons that you can check out. Make sure that you go to Circuits and then select Lessons, and then you can learn about breadboards, which are a really easy way to set up more complex electrical circuits that can do lots of different things. You can learn a little bit more about Ohm's Law, which is what we were just talking about when calculating the volts and the amps and the ohms and all that stuff. And then there's a little bit more that we can learn about for series and parallel circuits. And like I said, this is a pretty new module, so there's probably some more lessons that will be coming out in the near future. Thanks again for joining me. I hope you enjoyed learning about circuitry and electricity and how you can simulate circuits. You can find more content like this if you follow the hashtag GoBeyond with SCI on Facebook, Instagram, or Twitter, or if you check out our website, sciwa.org. Thanks again, and take care.